So we're going to be learning in this chapter how to deal with fractions that are algebraic expressions. And we're going to learn how to do all the things that we learned how to do in previous years with fractions, how to reduce fractions, how to add, subtract, multiply, and divide fractions. With that, we're going to learn all those things with rational expressions. And I'm going to do this today. I'd like to talk about reducing fractions and multiplying and dividing of fractions. Now, what I'm going to do is I will demonstrate the idea with just numbers, and then I'll give you examples that are using algebraic expressions. So let's talk about first what's called reducing, or sometimes also use the term simplifying fractions. If I were to give you something like this, 18 over 54, for example. And I said, I have this fraction. What's interesting about fractions is there are many different versions of a fraction. The fraction 1/2 is the same as the fraction 2/4. With regular numbers, we don't have that, but with fractions, we can have many versions of the same number. And what we try to do is get the fraction in its simplest form, because then we can compare whether two fractions are equal or not. And what we do is we look for a number that goes into both the numerator and the denominator, a common factor of both the numerator and denominator. Now, if you look in this fraction, the top is 18, and the bottom is actually 3 times 18, because 3 times 18 is 54. So I noticed that a common factor of both the numerator and the denominator is 18. When I see a common factor in the numerator and denominator, I can cancel it out. That means I can divide out the top by 18, that'll give me 1, and I can divide out the bottom by 18, and that'll give me the 3. And this fraction reduces or simplifies to 1/3. 18 over 54 is the same value as 1/3. So that's what's called reducing a fraction or simplifying a fraction. Remember what we look for. A common factor in the numerator and denominator that could be canceled out. Canceled out means it could just be crossed out, but really we're dividing the top and the bottom by the same common factor. So let's see if we had something that was a rational expression. And I'm using examples from the book. So actually, there are 2 types that we're going to look at. One type is going to be a rational expression that has just monomials. The numerator and the denominator are single terms. Let's say it had something like this. 5a to the 3rd b to the 3rd over 20a5 b. This is a rational expression. We want to reduce it. We want to simplify it. So what we do is we're looking for a common factor in both the numerator and the denominator. And the easiest way to do this is first look at the coefficients and then look at the letters. You can do when it's everything is monomial, so no pluses or minus in between the terms, then we can just deal with each piece on its own. So between the 5 and the 20, the coefficients, the common factor is 5. I'm going to cancel out the 5 on the top. That'll leave me a 1. And cancel out 20 divided by 5 gives me 4. That takes care of my coefficients. Then I compare the literal parts, the variables. What I want to do, if I have an a to the third and an a fifth, is find a common factor of those. Well, we found common factors before when we were factoring, so this is sort of the same idea. The common factor is the letter with the lower exponent. The lower exponent in this case is 3. So I cancel out the one with the lower exponent. A third divided by a third just cancels out. This 1 can suffice for all of them. And I want to divide out, so I divided out the a third in the top. I want to divide out the a third in the bottom. Remember, when I'm dividing variables, I'm really subtracting their exponents. So 5 divided by 3 is 2. I'm left with a2. Now notice the a to the second, the a squared, is in the bottom. The top, the a to the third, the lower one, totally canceled out. And the one on the bottom is the larger one. That's where my a to the second remains. I then go to the b's. Now there's a b to the third and a b, which is really b to the 1 power. So the lower exponent is the plain b. That cancels out. That gets crossed out. And I, again, subtract the exponents. 3 minus 1 is 2. I'm left with a b squared, but now the b squared is left in the numerator because that's where the higher exponent is. And now I just go across and see what I have. I have a 1 and a b squared. 1 times b squared. Remember, we're multiplying. These are all being multiplied. 1 times b squared is b squared. 4 times a squared is 4a squared. So my final answer in simplest form is b squared over 4a squared. Let's remember, always cross out the lower one, and the answer, the one that you're left with, is where the higher number or the higher exponent was. Okay, I'm going to give you one to try now. I'm gonna erase this because I just need this space. Suppose I gave you this example. 14 a6 b squared over 21 a 7b squared. See if you could simplify or reduce that fraction. Give you a couple minutes. Okay, I think we can work on this together now. Like we did before, we want to reduce this. We look first at our coefficients 14 and 21. And I think of a common factor, the largest common factor of 14 and 21 is 7. 14 divided by 7 gives me 2. 21 divided by 7 gives me 3. That takes care of my coefficients. Okay, now we look at the variables. First of all, the a's. We have an A6 on top and an A7 on the bottom. The lower exponent is the A6, so that gets crossed out, that gets canceled out. And I subtract that exponent from the bottom. 7 minus 6 is just 1. So I'm left with a to the 1, which is just an a, and it's left on the bottom. It always is left where the larger exponent is. Then we have the b's. So we have b squared and b squared. In this case, the lower exponent is the same for both. It's b squared, and both of them get canceled out. Let me make a comment. If every single thing gets canceled out from the numerator, you have to put a 1 there. If it gets canceled out from the denominator, you have to put a 1 there. Do not just cross things out. You can cross them out if there are other numbers, but if everything gets crossed out, make sure you put a 1 there, because you are canceling out. That means you're dividing, and when you divide something by itself, you're left with 1. You're not left with nothing. In this case, we actually were left with a 2 in the numerator, and in the denominator, we were left with 3a. So my answer should have been 2 over 3a. This was a 7. It wasn't a 1. For somebody who sent me the answer, it must have looked like a 1. If that would have been a 1, your answer would have been correct. Nikisha, okay? All right, I have to be careful to write my numbers very carefully. Okay, let's see what happens now if we have polynomials. What if I have not just single terms? What if everything's not connected just with multiplication, but I have polynomials? For example, if I have something that looks like this. Suppose I had 20y squared minus 45 over 10y squared minus 5y minus 15. Okay, this is again a rational expression, much more complicated looking because it has more than one term. My numerator is a binomial. My denominator happens to be a trinomial. But the concept of simplifying is the same. When I'm looking for a common factor in the numerator and the denominator, and the key word there is factor. In order to find the factors, we're going to totally factor the numerator, and then we're going to factor the denominator. That's why it was so important that we learned chapter 4. We have to be really good at factoring, because we can't do these type of problems if we can't factor. So looking at the numerator, first of all, I always look for a common factor first. Between 20 and 45, there's a common factor of 5. And when I factor out the 5, I get 4y squared minus 9. I'm going to go continue over here. Note when I look at this 4y squared minus 9 can be factored further because 4y squared is a perfect square and 9 is a perfect square. We have the difference of squares. So to complete this factoring, I'm going to leave my 5 on the outside, and my two parentheses are going to be 2y minus 3 and 2y plus 3. So totally, completely factor your numerator. Then go back and totally, completely factor your denominator. Well, in your denominator, there is again a common factor. It happens to be 5. And that will give me 2y squared minus y minus 3 as a trinomial. And that looks like that could be factored further, but I'm going to go over here and do it down here simply because when I have something like 2y squared minus y minus 3, where I have a leading coefficient, I have to do the AC method. So let's do the AC method. We're going to multiply the A, the 2, times the C, the negative 3. That'll give me negative 6. And I'll look for two numbers that'll multiply. Well, if it's negative, it'll have to be a positive number and a negative number. Remember, we always talk about the sign first. And then we're looking for them that multiply to 6, but when we subtract them, they're going to give us the number in front of the y, which is 1. Well, the numbers that subtract to 1 obviously are 3 and 2. And since this middle term is negative, the 3 is going to be the negative and the 2 is going to be the positive. So this will be rewritten as 2y squared plus 2y minus 3y minus 3. Now, it doesn't matter. You could have put the minus 3y first and the 2y second. It doesn't make a difference. Here are my two groups. In my first group, 2y is my common factor. So that becomes 2y times y plus 1. In my second group, 3 is a common factor, but it has to be a negative 3 because this starting term of this group is negative. So this becomes negative 3 times y, and negative 3 divided by negative 3 is plus 1. So that this factors into y plus 1 and 2y minus 3. That's what this trinomial factored into. So let's go over here and put it over here. This is going to, remember we have that 5 from before. Now we have a y plus 1, and we have a 2y minus 3. Now, first we look at the single terms, which in this case is just a 5 and a 5. When we're dealing with the single terms, the monomial, we deal with it the way we did before. Any common factor in numerator and denominator. In this case, 5 on top and 5 on bottom gets canceled out. Now, I really should be putting 1s in place of them, but I'll only really put a 1 when everything cancels out. If there's something left, I don't need that 1 because 1 times any number is that number. When it comes to the polynomials, which are really usually binomials, but any polynomial, you can only cancel out. They're only like factors if they are identical. So I go through each of my polynomials on top. I have a 2y minus 3 on top. Is there a 2y minus 3 on the bottom? Yes, there is. So I can cancel out the 2y minus 3 with a 2y minus 3. Notice, if this would have been a plus, I would not have been able to cancel it out. They have to be identical. The same numbers, the same signs. Now there's a 2y plus 3, but there's nothing to cancel it out. The y plus 1, there's nothing to cancel out. So if I look, my final answer is going to be 2y plus 3 over y plus 1. And these can't be canceled. I can't cancel out these y's. I can't do anything because binomials are units in their cells, and the only thing they can cancel out with are identical binomials. There is going to be one exception that I'm going to talk about, but really this is the rule. Are you ready to try one on your own? Everybody okay? So let me I'm going to have to erase this to put another problem on the board. Suppose I gave you this, a squared minus 4a minus 12 over a squared plus 8a plus 12. I would like you to simplify this fraction. Get it as a reduced fraction in lowest terms. While you're doing that, I'm going to take attendance. So my numerator is factoring to x minus 3 and x minus 2. And my denominator is factoring, well, this is the difference of squares. Now be careful. In this case, the 9 is first and the x squared is second. So when I go to factor it, I have to first break up the 9 into 3 and 3. And then there's going to be a plus and a minus, and the x squared is going to be x and x. It's the difference of squares. Do not switch the order. This is not x squared minus 9, it's 9 minus x squared. And when I go to reduce, I don't see any identical factors in both the numerator and the denominator. But I do notice something here. X minus 3 here and 3 minus x. Let's look at 3 minus x. Let's look at this factor. There is another way to write this. This really could have been written if we could have been rewritten. I'm going to show you a quick way of doing it in the end, but I want to explain the reasoning behind it. 3 minus x really means negative x plus 3. And when we have a negative starting our polynomial and we want to factor it, we always use the negative as part of the common factor. This is the same as saying negative 1 times positive x, and negative 1 into 3. So really, I could have rewritten this as the example. I could have rewritten this as x minus 3. Let me just do this part. Let's just look at the x minus 3 and the 3 minus x. Let's just look at that separately. Remember, I said 3 minus x could really be written as negative 1 times x minus 3. And if you notice, now there is a common factor of x minus 3. And what we're left with is a 1 on the top and a negative 1 on the bottom, which really gives me 1 divided by negative 1 is negative 1. And now let me just explain what you can do short. If you see that you have two binomials that really look alike, the only difference is that the order has been switched. This is an x minus 3. This is a 3 minus x. Those can be reduced. They can be crossed out as long as you put a -1 in place of one of them. Now you can put the -1 in the numerator, or you can put it in the denominator. Over here we have it in the denominator. Over here I have it in the numerator. It usually is easier to deal with if you put it in the numerator. So I will always put it in the numerator. Notice the x minus 2 and the 3 plus x don't have anything in common. They're not the same numbers. They're just, remember, this can only work if you have identical binomials with the order switched. So my final answer will become -1 times x minus 2 over 3 plus x. If this would have been an x plus 3, then it would have canceled out with the 3 plus x, because when you're adding, the order in which you add it doesn't make a difference. It's only the problem when they're opposite in order and one has, and there's a minus in it. There are other ways of writing this answer. I could distribute that -1. That would give me -1 times x is -x. -1 times -2 is +2. And I could have written, instead of 3 plus x, I could have written x plus 3 if I want to write it in descending order, where the x's come first and then the numbers. Remember, x plus 3 and 3 plus x are identical. X minus 3 and 3 minus x are not identical, but they are the same number, but one is positive and one is negative, so they can be canceled out as long as you put a -1 in place of it. When there's positive, you don't have to put the -1, but when there's a negative, you have to put the -1. Okay, I just want to go one step further and show you how we can multiply fractions. First, I'll start with monomials, and then I'll go on to polynomials. And after I finish that, then we'll go do some review. So if I have something like this, 10, well, let's just do plain numbers first. 10 over 5 times 15 over 2. The rule for multiplying fractions is to multiply the numerators together and to multiply the denominators together. But we sometimes do something that's called cross-canceling. We try to first reduce before we do the multiplication, because then we're dealing with numbers that are simpler. So I look at my 10 and I ask myself, is there any common factor between the 10 and anything in the denominator? And I notice, oh, the 10 here and the 2 here have a common factor of 2. That means I can cross this out. The 2 divided by 2 is 1, and 10 divided by 2 is 5. I then look at the 15, though I could have done the 5 and the 5, but I see here the 15 and the 5 have a common factor of 5. I cancel out the 5, and 15 divided by 5 is 3. And once I cancel out, there's nothing else to cancel out because my denominators are just 1. My answer becomes 5 times 3, which is 15, over 1. Now, when your answer comes out to have a denominator of 1, then you don't have to put that denominator, you could just write it as 15. If the numerator, the top, comes out to be 1, you cannot ignore it. You have to put it in. But if the denominator, the bottom is 1, you could write it just plain 15 because 15 over 1 means the number 15. When we have something like this, suppose I gave you something like this, 8y to the third over 7y to the fourth divided by, let's do a division, 16x squared. Oh, I'm sorry, this is supposed to be an x. I am sorry, this is supposed to be 8x to the third. And this is 16x squared over 14y6. This happens to be a division example rather than a multiplication example. But when you're multiplying and when you're dividing, you're almost doing the exact same thing. The only thing you have to do with division is take your second fraction, your divisor, and take its reciprocal. You rewrite this problem as 8x to the third over 7y fourth times, you make it into a multiplication, 14y6 over 16x squared. In other words, when you're dealing with multiplication, you leave them alone. When you're dealing with division, flip, take the reciprocal. That's what flip means. The second fraction, always the second one. Now you have a regular multiplication. We're going to do what we did before. We're going to see if we can cross cancel. Well, let's look first at the numbers. There's an 8 here. There's 8 in the numerator. I can only cancel things in the numerator with things in the denominator. Is there anything I can cancel with an 8 in the numerator? Yes, the 16 in the denominator. So I'm going to cancel out the 8 and the 16, and I'm going to put a 2 in place of the 16. I'm going to work myself straight across. Then I have an x to the third. I look, is there any x in the denominator that I can cancel with? Again, it has to be a numerator with a denominator. Well, yes, there's an x squared. And since the lower exponent is the x squared, that's the one I cancel out. And I do 3 minus 2, subtracting their exponents. And that gives me x to the 1, which is just x. Going further along my numerator, there's a 14 here. Is there anything I can cancel out with a 14? Yes, there's a 7 in the denominator. Remember, a numerator with a denominator. The 7 cancels out. 7 into 14 is 2. Notice the 2 is on top because the larger number is on top. Then we take the y6th and the y4th. Those have a common factor of y4th. I can cancel out the y4th. Now notice, this is totally canceled out, so I have to put a 1 there. I always put a 1 where there is nothing left. If there's something left, that's good enough. Okay, here, this is a 6. I have to subtract 6 minus 4. That gives me 2, y to the 2. Now, before I say I'm finished, I'm still looking. Is there anything on the top that can cancel out with anything on the bottom? And it could be any numerator with any denominator. And I see a 2 in the numerator with this 2 in the denominator. I can cancel out the 2. This gives me just a plain 2, leaves me a y squared. This 2 cancels out. I'm left with a 1 there. Remember, when everything is totally canceled out, I like to put a 1 there. And now you have to be very careful because it can get rather messy. Let's see what we're left with. In the numerator, I have an x and a y squared, so that's xy squared. And in the denominator, I have 1 times 1, which is 1. And remember, when the 1 is in the denominator, I don't have to put it in. I could just write my answer as xy squared. That's how we multiply and divide rational expressions. I'm going to do one other example, and then I'm going to give you one to try. And after we do that, then we'll go on to our review for the midterm. Okay, what happens if I have a polynomial? So let's take this example. Three x minus 12 over x squared minus 4 times x squared plus 6x plus 8 over x minus 4. Okay, this is again two rational expressions, and we're multiplying them. And since these have polynomials, the first step we're going to take is to simplify by first factoring everything we possibly can. I'm going to write the factoring thing over here. So in the 3x minus 12, my common factor is 3. So this becomes 3 times x minus 4. Then we have x squared minus 4. Now, x squared minus 4 is the difference of squares, and therefore I'm going to factor this as x and x. One's a plus, one's a minus, and we'll break up the 4 into 2 and 2. It's the difference of squares. Okay, now we go to our x squared plus 6x plus 8. That's a trinomial that starts with a plain x squared, so I'm going to put x and x. Looking at the sign, the last term is positive, means both signs are the same. The middle term being positive means they're both pluses. And the numbers that multiply to 8 and add to 6 are 2 and 4. And finally, my bottom is just x minus 4. There's nothing more to do with it. I've done all the hard work. Once the factoring is complete, then I can start reducing. There's a 3 on top, but there's no 3 on the bottom, so I just leave that alone. The next thing I see is an x minus 4. There is an x minus 4 in the denominator, so I can cancel it out. Now this denominator is totally gone, so I'd like to put a 1 where everything is totally gone. If there's something left, like over here, the 3 is, I don't have to put that 1 there, because 3 times 1 would still be just 3. Then I have an x plus 2. Is there anything I can cancel out the x plus 2 with? And yes, there is an x plus 2 over here. So I cancel this out with this. And finally, I have an x plus 4 and an x. There's nothing to cancel that x plus 4 with. So my answer is, I'm left on the top with the 3 and the x plus 4. That's my numerator. And I can leave it like this in factored form. And in the denominator, I have an x minus 2 times 1, which is just x minus 2. So this is my final answer. Do you think you're ready to try one on your own? Any questions? Okay, so here's an example I'm going to give you. Okay, we have 5x minus 10 over 6x minus 9 divide by 6 minus 3x over 8x minus 12. I'm going to give you a couple of minutes to try that on your own. Since this is a division problem, the first thing we want to do is flip the second fraction. This becomes 5x minus 10 over 6x minus 9 times 8x plus minus 12 over 6 minus 3x. And now we want to factor each one of these numerators and denominators. Now the 5x minus 10 has a common factor of 5. So that becomes 5 times x minus 2. In the 6x minus 9, we have a common factor of 3. So this becomes 3 times 2x minus 3. In the 8x minus 12, we have a common factor of 4. So that becomes 4 times 2x minus 3. And finally, in 6 minus 3x, we have a common factor of 3. And this becomes 2 minus x. After I finished factoring, I looked to see if there's anything that can cancel out. Now there's a 5 here, but there's no 5 in the denominator. There's a 4 here, no 4 in the denominator. So that takes care of the monomials, just the plain numbers or the numbers and letters that don't have any pluses or minuses. Now let's deal with the polynomials. Actually, all the polynomials here are binomials. There's an x minus 2 here. There's no 2 minus x in the, there's no x minus 2 in the denominator, but there is a 2 minus x. And remember, we said we can cancel those out as long as we put a -1 in place of one of them. I always like to put that -1 on the top. Now notice this is going to be a 5 times a -1. This -1 is a factor. It's not, you're not doing 5 minus 1, you're not subtracting. Now I go over. There's a 2x minus 3 here and a 2x minus 3. Those can just cancel out because they are identical. And now all we have to do is multiply all the things on the top. 5 times -1 times 4 is -20. And the bottom 3 times 3 is 9. You could also write this as -20 over 9 with a negative in front of the fraction instead of in the numerator. It means the same thing. And that would be our answer, either this one or this one. For homework, aside from what, okay, great, Carmelita. For homework, aside from the Delta Math test and the practice midterm, which I'm going to give you, as I said, sometime it's going to be sent out. Today, the Delta Math test will be available after 2, and the Blackboard practice midterm is going to be available sometime tomorrow. Let me just comment on that. What you're going to see is when you see that test on Blackboard, it's going to give you a time limit. It won't tell you, you'll have to do it. I'll probably give you a few days in which to pick to when you want to do it. But once you start it, you're going to have a total of 75 minutes to complete it. If you walk away from it in the middle, it'll just the time will just run down and you will not be able to get back to it. You must complete it all in one sitting. If you are entitled to extra time, I want you to make sure to email me so that I can set up your test with, if you are entitled to double time, that you can have double time for it. Now remember, it is going to be considered a test. In other words, the mark is going to go down on your, as a test mark. But it's really a practice midterm. It's giving you an idea of what the midterm is going to be like. It's going to be a total of 20 multiple choice questions. All right, let's do some review of some of the topics that, oh, as I was saying, what I also would like you to do for homework are, I sent out the next exercise sheet, the homework sheet from chapter 5, and if you, I would like you to do examples 1 through 6 for Tuesday. That again, that we'll go over those questions on Tuesday. Now I'm going to erase this so that we can have some time to review. We have about a half an hour left. Let's review some of the type of questions that you might see on the midterm. It's on chapters 1 through 5. 1 through 4. Chapters 1 through 4. Now in chapter 1, what we did is we reviewed how to solve linear, regular, first degree, regular equations. Assuming everybody knows how to do that. We also learned in chapter 1 how to solve inequalities and also how to solve absolute value equations. So let's do, I'm going to give you a couple of minutes to try 2 examples and then we'll go over them. So the first example that I want you to do is to solve this inequality, -4 times 2x minus 4 is less than -12x plus 28. I'm sorry, 28, not 8, 28. And I'd like you to put it in interval notation and also to graph it on the number line. Put it on the number line and put it on interval notation. The second example I'd like you to do is to solve this absolute value inequality equation. It's 3 minus 6 over 5x plus 9 equals 11. So I want you to solve this one and this one. I'm going to give you a few minutes to try those. To get started on working these together. Looking at this first example, solving an inequality is very similar to solving an equation. We do the same steps. We first remove the parentheses, so we're going to multiply everything by -4 using the distributive property. -4 times 2x is -8x. -4 times -4 is positive 16. And that'll give us -12x plus 28. And we always want to manage to get the x's on the left side and the numbers on the right side. So I'm going to add 12x to both sides. That'll get rid of the 12x over here. And I'll subtract 16 from both sides to get rid of the 16 over here. So that I end up with -8x and 12x is 4x. less than, remember, I don't change the direction of the inequality, 28 minus 16, which is 12. And then I subtract by 4. I divide by 4, which gives me, let's go over here, x less than 3. Remember, when I divide by a positive number, I leave the direction of the inequality the same. If this would have been a negative number, I would have switched the direction of the inequality when I divide by a negative number. I switch the sense of inequality only when I'm dividing by a negative number. The solution is x less than 3. On the number line, what that'll look like is here's 1, 2, 3. Here's your 3. Since it says x less than 3, and it doesn't say less than or equal to, I make an open circle. And this arrow is pointing to the left. That's what it would look like on the number line. In interval notation, here we're going to be careful. Remember, the interval always starts on the left and works its way to the right. All the way to the left, because this arrow is pointing all the way to the left, is negative infinity. It ends at 3. Since this 3 is not included, just as less than 3, it's an open circle, it's not including, we use a parentheses. If this would have said less than or equal to, we would have filled in the circle and we would have used a bracket. So that would be the solution in interval notation. Okay, so when it says interval notation, you want to do this. When it says a graph, you want to do that. When it comes to the absolute value equation, we want to solve this by first making sure that we have our absolute value all by itself, which means I have to bring this 9 to the other side. I do not break it up into 2 equations until I have my absolute value all by itself. Now 11 minus 9 gives me 2. Now I pause here. I pause here and I look at this number. The absolute value, once I get it isolated, once I have the absolute value all by itself, I look at the number on the other side. That number has to be a positive number. We cannot have an absolute value equaling a negative number. If this would have, for some reason, turned out to be negative 2, I would have stopped right there and I would have written my circle with my line through it, which means no solution. That only this is going to have a solution because it equals a positive number. So always check, can you go further before you actually do? Now this one, as we said, we can go further. I'm going to erase this part because I'm probably going to need this space. Okay. What I'm going to do, go over here, is when I have an absolute value equation, I break it up into 2 equations. One equation I get by setting 3 minus 6 over 5x equals 2. I just rewrite the equation without the absolute value signs. But that's only one part of the answer. The other part of the answer, I have to get 2 solutions. I get by doing 3 minus 6 over 5x equals negative 2. Remember, if this would have been a negative number, I would have stopped. I can only continue when it equals a positive number. Now I'm going to solve this. I'm going to bring this 3 to the other side. This will give me negative 6 over 5x equals 2 minus 3, which is negative 1. I'll put that negative 1 over 1. So, and then I'm going to multiply both sides by the reciprocal. I'm going to multiply this by negative 5 over 6. Now, when I multiply by negative 5 over 6, the negative, what I'm going to get is the 5 will cancel out with the 5, and the 6 will cancel out with the 6. And the negative times the negative will give me positive, so that'll give me x. And on the other side, I have negative 5 over 6 times negative 1, which gives me positive 5 over 6. So one answer to this is 5, 6. On the other side, I do the same thing. I bring 3 to the other side, and I get negative 6 over 5x equals negative 2, and negative 3 is negative 5. Again, I'm going to put this over 1, and again, I'll multiply by the reciprocal. So I will multiply by negative 5 over 6 on both sides. Now, negative 5 over 6 times negative 6 over 5 just, again, gives me plain 1. So that's x. And negative 5 over 6 times negative 5 over 1 gives me positive 25 over 6. So here's my second answer. You have to be a little bit careful with your fractions. Is there any question about this? Okay, so we have a few more minutes. Let's try another example. Here's a question about the perimeter of a rectangle. The perimeter of the rectangle, I'm writing out just the important words. The perimeter of this rectangle is 28 centimeters. The length is 10 centimeters longer than the width. And I want to find the dimensions. What are the dimensions? Now, we've done these type of questions before. Let's do this together. Remember what we do? We draw ourselves a little rectangle. And since it's telling us the length is 10 more than the width, let's call the width x. And 10 more means add 10 to it, so the length is going to be x plus 10. If it said 10 less, then I would have done x minus 10. So be careful. More, I add 10, less, I subtract 10. Now this side will also be equal to x, and this side will be x plus 10, because in a rectangle, the opposite sides are equal. And the perimeter is everything added up together. So I'm going to add up all these sides. So I'm going to have an x, an x, an x, and an x, which gives me 4x. And 10 is 20. The four sides add up to 4x plus 20. That's going to equal 28. That's my perimeter. And I solve this equation, which will give me 4x equals 8. And that'll give me x equal to 2. Which means this is equal to 2. My width is equal to 2. And x plus 10, 2 plus 10 is 12. So my dimensions are 12 by by 2, sometimes also written 12 with a but sometimes they use an X in between them. The dimensions mean both the length and the width. Okay, I'm going to stop right now. We have one topic left that we have to review for the midterm, and that's writing the equations of lines. How do we write linear equations? That's what we're going to review on Tuesday. Again, I'm going to give you this practice review midterm. It's going to be available as soon as tomorrow. Does anybody have any questions as to what is in store for them? Remember, Delta Math test will be available this afternoon. It has to be completed by 10 o'clock tomorrow night. The Blackboard practice midterm will be first available tomorrow, and it'll have to be completed by next Thursday. I will give you, and you will have more information. As I said, the midterm itself will be on chapters 1 through 4, and it will be given the week of October 18th. Okay, have a nice weekend, everybody.
You too, Professor.
Okay, thank you. Is there any question as to what you're expected to do for next time?